So I grew up in a small town in England called Hereford, kind of on the border with Wales, so the west side. Very rural place, lovely place to grow up actually. I got into golf actually because my dad, he got into the game more, and as he got into the game more, he'd kind of pull me along with him. Went to university. I went to university to study mathematics. Maybe about a year before the end of my PhD, I really started thinking, what kind of sports would need a PhD mathematician? And so I wrote off some letters to some golf companies. Ping were the ones who actually had a need for someone with my skills and gave me a call, and the rest is history. All right, this is one of my favorite rooms in the building. Effectively, Pingman's a one-armed robot. He's swinging with his left arm, and he can go up, with one hand, he can go up to 150 miles an hour or more. We've had Pingman flying the fence here before. At the end of the day, the player testing is the acid test of whether a club performs, but this gives us some great scientific data. In my role now, I get a lot of variety in my day-to-day. Because I oversee all of engineering, we have 7 different departments, everything from going out to the assembly line and looking at what we're doing to try to really improve our custom-built piece of the pie. This is where the whole process starts. So each one of these trays here is what's going to be a set of iron. Through to interacting with the innovation team on what's our latest idea for a true breakthrough innovation and how we're going to test it, to interacting with our design team and looking at how does a club really come together to get to market, and everything in between. There's a lot of cross-functional work. The rules of golf are pretty complicated. There's a lot of them. You know, there are limits on spring-like effect of a club. You know, we can get all the way to the limit on that. But then that spurs innovation in other areas of, okay, so let's get creative and look at what else can we do. So we started looking more at aerodynamics. We load a sample in here, a plate, maybe a groove pattern, maybe a material we're testing, and we see how it reacts when the ball is fired at it and bounced off. So we're getting coefficient of restitution, we can angle this plate and we can look at friction and how a groove profile interacts with the ball and generates spin. This is a really controlled environment, so great for testing one variable at a time. I think when you reach one limit in one area, we just start to shift our focus to another area. Our biggest challenge right now is making sure that we can prove that this year's product beats last year's product. We've forced ourselves to have to keep improving year on year because that's the company philosophy. We won't launch something new until it's better, and we're not holding anything back each year.